my dear students. So yesterday, you know that we had finished with the benzene. I told you benzene undergo electrophilic substitution reaction. Benzene has four reactions, and what are those? The first reaction is with chlorine, bromine, then halogen derivative, and then the last one, that is nitric acid. Okay. So we did all those reactions. And then we started with the next chapter yesterday, second chapter, that was the methyl benzene. Before starting this chapter, I told you that with benzene, if any side chain that is attached, okay, so that side chain makes the benzene more reactive, less reactive, or the reactivity of the benzene would remain unchanged. I told you the way if an element having lone pair of electron directly attached to the benzene, okay, so it will delocalize its lone pair to the benzene ring, due to which reactivity of the benzene would increase. I told you yesterday. Okay, so if an element having no lone pair attached to the benzene ring, having no lone pair, and it does not need any electron as well. So the reactivity of benzene would stay same, like methyl benzene. In methyl benzene, carbon is having no lone pair. Okay, and just like that, if the benzene group AlCl2 is attached, aluminium, it is not having any lone pair, but it needs a pair of electron to get the stable electronic configuration or to complete its octet. So what does it do? It is going to attract the electrons from the benzene ring towards itself. So due to which the ring is having less number of electron now, and the reactivity that would decrease. Okay. So the side chains, they increases, decreases, or the unchanged reactivity of the benzene group. So we did it yesterday. So today, my dear, we are going to start with this chapter, chapter 2. Okay. Methyl benzene. The first thing we are going to start, that is the preparation of methyl benzene. So any one of you could tell me methyl benzene, how would you prepare it? Let's suppose we got the benzene. Okay, this is the benzene. So with which substance the benzene should be reacted to form methyl benzene? Any one of you?
CH3Cl.
CH3Cl. CH3 and Cl, because I told you yesterday that benzene could react only with chlorine, bromine, halogen derivative. So halogen derivative or halogen alkane, here you need the methyl. So you should take the methyl and join it with the chlorine. Okay. So AlCl3, that would be used as catalyst. Okay. So the methyl group is attached with the benzene ring, my dear. Okay, so methyl benzene that would be formed, and you will get HCl. Okay, so this is the preparation of methyl benzene. Is it clear, my dear? Yes. So this is the preparation. I'm not going to specify the whole mechanism of here. Okay. Now, the next thing, that is the reactions of methyl benzene. So methyl benzene, my dear, it has got the two types of the reaction. Have a look up here. This is the benzene. This is the methyl group. So methyl group, it's actually the side chain. So the reactions with respect to side chain, they are different. With respect to side chain. Okay. So the side chain, it is the alkyl group. It has got different reactions. Okay. Whereas this is the benzene group. Okay. So benzene group has got different reactions like benzene alone. Okay. So the reactions with respect to benzene group. Okay. So the reactions with respect to side chain and the reactions with respect to benzene group, they are entirely different. Okay, so one by one we are going to discuss them. So let's start, my dear students. First of all, the reactions with respect to side chain. So reactions with respect to side chain. Okay. Okay, my dear students, reactions with respect to side chain. So the first reaction that we are going to start, that is with chlorine, Cl2. So I want every one of you to concentrate up here. If you look up here, this is, my dear, benzene. Okay, this is the methyl group. If you take the chlorine, so I'm going to draw it two times, methyl benzene. So methyl benzene. This is methyl benzene. Chlorine is going to attack on it. Chlorine is going to attack on it. Okay, my dear students, if you look up here, the reagents, they are exactly same. Reagents mean those things which could react. Okay, the reagents are exactly same, but if the conditions they are different, if you are going to use the UV light, so in the presence of UV light, this chlorine is going to attack on this methyl group, and the reaction would take place, which is called as the free radical substitution. Okay, free radical substitution. On the other hand, if you have got this chlorine and you use AlCl3 as a catalyst, so this chlorine is going to attack on the benzene ring. So this is called as the electrophilic substitution. So due to the change in condition only, in the presence of UV light, chlorine is going to attack on the methyl group. And the free radical substitution, you studied it in your A1. Here we are going to start it again, but you done it in your A1, free radical substitution. One hydrogen would come out, free radical would be formed. So all these things we will discuss it. Okay, but if you got AlCl3, this Cl2 would attack with the benzene. Okay, so the reagents are same, but the conditions difference could make the different type of the reaction. So now, my dear, we are going to start with the free radical substitution. Can I have this one? Okay, my dear students, so let's start with the free radical substitution. Okay, in the free radical substitution, you know that there are the three steps involved in it. The first step, that is called as the initiation. The second step that is involved, that is propagation. And the third step involved, that is the termination. Okay. So now one by one we are going to start with these steps. In the initiation, my dear, what would happen? This is the chlorine molecule Cl2. Cl2 means that Cl and Cl, they got one electron shared between them. Okay, guys. So this chlorine and chlorine has shared one electron in between it. So what would happen when you are going to throw the UV light on it? So in the presence of UV light, so this bond is going to break in such a way that every atom gets its electron back. Okay? And when every atom gets its electron back, my dear, so you will get the chlorine free atom, which is called as the free radical. So this is the free radical. So free radical that is being generated. Okay, so this is the free radical. This free radical, my dear, it is very reactive. Okay, so what does it do? It is going to attack on the methyl benzene. So this is the benzene. This is the methyl group. So the free radical from here, it acts as a burning splinter. It attacks on the benzene. Always keep remember the radical thing will take out something from the other thing. So it will take out the hydrogen from it to form HCl, and we will get the benzene, and you got CH2 attached with it, and this one is the free radical which is being produced. Now this free radical, my dear, it is reactive now. So what does it do? This free radical, it is going to attack on the chlorine molecule. So always keep remember whenever a carbon free radical is present, it would always attack on the chlorine molecule. So it will attack on the chlorine molecule and we will get, so this is the free radical now. So this free radical will take out something from this state. So you will get benzene, and this is CH2, not, yeah, CH2, Cl, and the other chlorine that will change into free radical. Now this radical is going to attack on it in the next step. So this is CH2, Cl, and the Cl free radical. Okay, so this radical will take out hydrogen from it, so it will form HCl. Okay, and you will have benzene and CHCl is the free radical. Now this carbon free radical, it will attack again on the chlorine. So this one is continue. You can complete it from your home. This whole thing. Okay. This one attack on the Cl2. So this whole process would continue until these all hydrogens, they are replaced by the chlorine. Okay. So this whole thing is called as the free radical substitution. You have done it in your A1s. What is the termination, my dear? In the termination, the free radicals, they would join with each other. So this free radical could join with it. This free radical could join with it. This free radical could join with this one. So all the free radicals, they could join with each other. You can write down any one or two reaction. Let's suppose we could write this one. So have a look up here. This is benzene, CH2 free radical, and then again benzene, CH2 free radical. So they would join with each other. So this is benzene, CH2, CH2, and this is benzene again. Okay, and just like that, Cl free radical could join with Cl free radical to form Cl2. Okay, so you can get the products in the termination step. They are double. The two benzene group, they are present in one compound. Okay. So this is the termination step, but this whole reaction, free radical substitution, it would take place when you got the chlorine and UV light. Then this reaction would take place. So all the hydrogen, they are replaced one by one with the chlorine. Did you get it? Yes, sir. Yes. So this is an extra thing which is based on the free radical substitution reactions. Okay. So this is not the part of the reactions we are doing, the reactions with respect to side chain. These are some different reactions. Whatever the products they are formed in free radical substitution, they got some reactions in paper. Such kind of the question has come. So that is why I'm going to brief it to you. Okay. So in the free radical substitution, my dear, you got these kinds of the compounds which are being formed. CH2, Cl. So one chlorine will attach. The second thing, you can get the two chlorine being attached like CH and Cl2. And then you got benzene and CCl3 that is being attached. Okay? Okay, my dear students, now everybody just listen. These are the three products of the free radical substitution. One of the hydrogen is replaced by chlorine. Two hydrogen are replaced by the chlorine. The three hydrogens they are replaced by the chlorine. So these three products they are produced in the free radical substitution. Now this thing is with respect to your A1. I told you in the A1 that if you people are going to add sodium hydroxide aqueous or potassium hydroxide aqueous. Okay, so if you provide sodium hydroxide or sodium or potassium hydroxide aqueous, so both of them they are alkali. They are going to produce the OH minus ions. Okay, so keep remember, my dear students, the OH minus is an electrophile. Is it OH minus is a sorry? It's electrophile. It's a nucleophile. Sorry. OH minus they are stronger nucleophile than Cl minus, Br minus, and OH minus. So OH minus are stronger nucleophile than Cl minus, Br minus, and I minus. So what they do, my dear, they are going to replace the Cl. Okay, so what would happen? The Cl minus that would come out, and you will have benzene and CH2OH. So anybody could tell me the name of this one? I told you if the alcohol group is attached with the carbon chain, so that thing would become phenyl methanol. Did you remember? Okay, now come up here. Here we got the two chlorine. So two OH minus, what they do, they are going to replace these two chlorine. Okay, so two chloride ions would come out, and what you will get? This is benzene. This is carbon, so it got one hydrogen. So I'm going to make it display all these things. So this is OH and this is OH. This is being formed. Now one thing up here. Keep remember, if with one carbon the two OH group they are attached, that is unstable. दुनिया में कोई भी चीज अगर एक कार्बन के साथ टू OH ग्रुप टू एल्कोहलिक ग्रुप लगे हुए हैं तो वो कभी भी स्टेबल नहीं होती. सो व्हाट डज इट डू? एवरीबॉडी जस्ट लिसन. The OH from here and H from here, so that would form the water. ये वाटर बना देगा और ये जो चीज है ये किसमें चेंज हो जाएगी? वाटर बना दिया. And what we will have at the end, this is benzene, this is carbon, this is oxygen, and this is hydrogen. तो ये CO के साथ डबल बॉन्ड बनाता है, तो डबल बॉन्ड बना देगा. So this thing would change into benzaldehyde. Did you get it? Just like that, if you look at this case, the same thing would happen. The three OH minus, they are being used, my dear. So they are going to replace the three Cl minus. And what is the thing left up here? This is benzene. Okay, this is carbon, this is OH, this is OH, and this is OH. Okay, so the OH and H, so they are going to form the water. So you will have the water up here, H2O. And what you will have at the end, this is benzene. You got carbon, this is O, and this one is OH. So with the oxygen, it formed the double bond. So this whole thing is called as this is the carboxylic acid group, C double bond O and OH. So this thing formed, that is, my dear, benzoic acid. Did you get it? So this is an extra thing. That is why I just make a circle around it. Okay. So these three products formed during the free radical substitution. If you put sodium hydroxide or potassium hydroxide in it, okay, and heat it up. So these are the nucleophilic substitution reactions You have done it in your A1s. Halogen alkanes, they always undergo nucleophilic substitution. So you have done it in A1s. Okay, guys, the second reaction we are going to start. The first reaction we did with the chlorine. These are the reactions with respect to side chain. पहला रिएक्शन क्लोरीन के साथ था और वो क्या हुआ है फ्री रेडिकल सब्स्टिट्यूशन. द सेकंड रिएक्शन दैट इज माय डियर द oxidation of alkyl benzene. So always keep remember, my dear student, whenever any alkyl benzene it undergoes the process of oxidation, it will form the benzoic acid. It is the first thing. The second thing, only primary and secondary alkyl group, they undergo the oxidation. The tertiary one doesn't undergo with the oxidation. Let's suppose if you look up here, this is carbon, this is CH3, this is CH3, and this is CH3. Okay, so this whole thing, that is the alkyl, because this one is the alkyl group, alkyl benzene. Okay, so if you look at this carbon which is attached with the benzene, this carbon is tertiary. It is surrounded by the 3 carbons on its sides. So this one can't undergo the process of oxidation. If this one contain like this one, carbon, hydrogen, CH3 and CH3. So this thing can undergo the oxidation reaction. Why? Because it contains one hydrogen. So this is the secondary alkyl benzene. And if you got the 2 hydrogens attached with it, like that, and 1 carbon is attached, so this one would be primary. Okay, so the tertiary carbon in the alkyl benzene that does not have the process of oxidation, uski oxidation nahi hoti. The primary and the secondary carbon attached with the benzene, it undergo the process of oxidation, and whenever the process of oxidation it would take place, you always get the product benzoic acid. How? The first thing, oxidation of alkyl benzene, that would always take place with acidified potassium magnate ions. Okay, and the conditions for this one, they are heat under reflux. Okay, so it could be oxidized only with potassium magnate, not with dichromate. If you got the dichromate, this alkyl benzene could not be oxidized. Now I'm going to take the 3 examples up here. Everyone just look. So taking the 3 examples for you people, just to make you understand. This is the methyl benzene. So I'm going to display it so that you may understand it. This is hydrogen, this is CH3, and this is H. So this is the ethyl benzene. So this one carbon, this is CH3, this is CH3, and this is CH3. Okay, so we got the 3 different alkyl groups. Okay, so this is the first one. So whenever the oxidation takes place, my dear, just listen it carefully. The oxygen atom that comes from this acidified potassium magnate, MnO4 minus, and the conditions, they are heat under reflux. Okay. Okay, guys. So this is the benzene group. आपने क्या करना है? What you are supposed to do with the benzene? The carbon is attached, so you should save 1 carbon and hydrogen attached with it. इसको save कर लें, and all the other carbons and hydrogens which is outside from it, you should join them with the oxygen to form carbon dioxide and water. So here we got the 2 hydrogen. So they would join with oxygen to form water. So you will get water. So what the thing is left up here? Benzene, okay, and carbon, and this is hydrogen. Okay. So now what would happen? What would happen? Listen, this carbon and hydrogen is present, so oxygen that would form a double bond with this carbon, and oxygen would be attached up here. So this whole thing, my dear, that would form the benzoic acid. And total, how much oxygen are used? 1, 2, and 3. So put 3 up there. Did you get it? Yes. So you should say one carbon and hydrogen attached to the benzene ring directly, and except for this carbon and hydrogen, you should join all the other carbons and hydrogen with oxygen to form carbon dioxide and water. Now do the next one. Oxidation, my dear. So acidified potassium magnate that could be used, and the conditions, they are heat under reflux. Now what could happen? You should save this one carbon and one hydrogen. So all the other things, this carbon would join with oxygen to form CO2. 3 hydrogen and 4 hydrogen, these would join with oxygen to form 2 water. And what would be left? You got benzene, and with the benzene, one carbon and one hydrogen is present. So it would form oxygen double bond. This one oxygen is attached up here. So total, how much oxygen are used? 2, 2, 4, and 2, 6. So 6 oxygens, my dear, they are being used.
लास्ट वाला तो रिएक्शन होगा ही नहीं।
लास्ट वाला रिएक्शन होगा ही नहीं, क्योंकि ये जो कार्बन है इसके पास कोई हाइड्रोजन नहीं है, तो इसकी ऑक्सीडेशन ही नहीं हो सकती, नो ऑक्सीडेशन। क्योंकि मैंने आपको बता दिया कि सिर्फ प्राइमरी और सेकेंडरी जो कार्बन्स होती हैं बेंजीन के साथ अटैच, दे कुड अंडरगो द प्रोसेस ऑफ ऑक्सीडेशन।